Next, we're going to look at a couple other ways to prove that triangles are similar to each other. The last one that we had was angle-angle. So if you think about the ways that we had to prove things were congruent, that kind of eliminates the need for angle-angle side or angle-side angle, because we don't even need the side, we just need the angle-angle. So we're going to have fewer of these because it's easier to prove that something's the basic same shape than it is to prove that something's congruent. Okay, so there is a side-side-side similarity theorem, but we don't want the sides to be congruent because that would make the triangles congruent. We want the sides to be proportional. Okay, so our side-side-side similarity theorem is going to say if the lengths of corresponding sides in two triangles are proportional, which means they have a constant ratio, then the triangles are similar. So if I have two triangles and there's a constant ratio between all their corresponding sides, okay? So this is a constant ratio of 1 to 3. 2 over 6 is still 1 to 3. 3 over 9 is still 1 to 3. These triangles would be similar by side, side, side. Okay, so there's a side angle side similarity. So if two corresponding sides are proportional and the included angle so included angles are congruent, then the triangles are similar. Okay, so remember it's got to be the included angle. So the same rule applies. There's no ASS similarity. There's only side angle side. So if we've got two triangles again, try to draw them the same shape here. Okay, two triangles again, and I've got two sides that are similar, or proportional. Okay, so if this is 2, 8, and this is 4, 16. Okay, they're a constant ratio, a 1 to 2 ratio, or a 2 to 1, depending on which way you're going. And I have the angle that's in between the sides. Okay, it has to be the included angle, the one that's between the proportional sides. Okay, those are congruent. Then I can say that these triangles are similar by the side angle side similarity theorem. Okay, if it's not that angle, so if it's this one over here to this one or this one to this one, I do not have similar triangles. All right, so all the ways to prove triangles are similar. We've got angle, angle. We've got side, side, side. Okay, so this one's kind of hard to draw. If we name this ABC, we'll call this D, E, F. Side, side, side would be if AB over its corresponding side, which would be ED, Okay, that ratio is the same as the ratio of BC over EF, and that has to be the same as AC over DF. Okay, if we have the same ratio when we match up the corresponding sides, this would be side, side, side. This leads to side, side, side. Okay, here I've got a right angle. I can count that as my angle. Okay, so the last one I need is side, side. So I need PQ over ST to be equal to QR over TU. Okay, so what's nice about right angles is if I have a right angle or perpendicular, I already have one angle. So all I need is one more angle, or I need to get proportional sides around it, or 3 proportional sides. Okay, so let's look at an example where I could use any one of these. So prove that triangle DFR, which is the whole triangle here, is similar to MNR, which is this little one here. Okay, so I'm going to fill in the missing information that I have. First, if this whole thing's 10 and this is 2, that makes this 8. Okay, so I'm going to write that in. Let's first prove this by angle, angle. Okay, so here's our angle, angle proof. So I'm going to say that DF is parallel to MN. Okay, because these are both right angles, and if I look at MN and DF, these are corresponding angles. So this is the corresponding converse. Well, if those are parallel, then here's a different transversal I can use, and I can say that angle F is congruent to angle RNM. So these angles are congruent, because they are corresponding. Then I can say that the triangles are similar because I have 2 congruent angles, so by angle, angle. All right, let's prove it by side angle side. So I've got the right angles. Okay, so I'm going to say angle D is congruent to angle RMN because they're both right angles. Okay, and then what I'm going to say is 8 over 10 equals 12 over 15. Okay, because, well, really it's just simplification because, so I'm going to write this whole thing out. 8 over 10 is really, if I divide both of those by 2, I get 4/5. If I divide both of these by 3, I get 4/5. Okay, so this is just simplify. We could also prove it by the cross product property. If I cross multiplied, okay, I'd get 8 times 15, which would be 120. And 10 times 12 is also 120. So you could write your reason as a cross product property. So at this point, I've got proportional sides with an included congruent angle. So I can say the triangles are similar. By side angle side. Okay, let's do it by side, side, side. So in order to do by side, 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 I'm going to need to know what these third sides are. Okay? In order to do that, I've got a right triangle. I can use my Pythagorean theorem. So I've got 8 and 12 for my A and B. So 8 squared plus 12 squared equals C squared. 64 plus 144 is C squared. So 208 equals C squared. Square root both sides here. This turns into, let's see, 4 goes into this 52 times. 52 is 13 times 4, so now I've got a pair of 4s. This is 4 squared of 13. In the big triangle, I've got 10 and 15, so I'm going to do Pythagorean theorem with that. 10 squared plus 15 squared equals C squared. 10 is 100. 15 squared is 225. Okay, so this is 325 equals C squared. If I square root both sides here, 325 is 25 times, every 100 is 4, so that'd be 12, plus 1 more is 13. 25 is 5 and 5, so this is 5 squared of 13. Okay, so let's put my hypotenuses together. 4 squared of 13 over 5 squared of 13. Okay, that equals 4/5 because the squares of 13 cancel. Okay, from up here I had 8 over 10. That reduces to 4 over 5. And I had 12 over 15. That reduces to 4 over 5. Okay, so all of them make the same ratio. So this is simplifying, and then I can say that the triangles are similar by side, side, side. Okay, so you can use any one of these, whichever one works best for you. I think the quickest one in this case was probably side angle side, because we just have to set up our proportion. We've got the angle in the middle.